Well, Brian is on his way in to pick up his XLT, but before he gets here, I wanted to explain the impetus behind the design of this sander, why I designed it the way I designed it, and what I use it for. It was number one, to be able to radius the foot of those acoustic guitar bridges, and number two, as you've already seen in multiple videos, to use the edge to create the radius for the compensated nut ledges, or even just a stock strat nut, to be able to put that radius on the bottom side of the nut so it matches the radius of the slot. But it really is a multiple use sander that I use for countless other things. And it frees up both hands, so I don't reach for a switch to turn it on. It's right underneath my foot. So any of those little bits and pieces that you're sanding, now you do it in a fraction of the time. And it's quick to install and quick to take out. It's there when I need it, and I can set it aside when I need my drill press for other things. This actually comes with this air foot switch that I'm using. So for everyone that ordered from this first batch, I just want to show you how quickly I set this up. That hex drive, of course, is a positive lock. Before you tighten the chuck down, after raising the table, you want to make sure that you snug that down to ensure that the table is 100% perpendicular to the axis of the chuck. You want to tighten that up. Now that can still move around a little bit, and that's fine. So I'm leaving that loose. We just snug that down, and now we've got a positive lock. The three jaws of the chuck coincide precisely with the hex drive that drives the disc. The design behind this is such that you don't put any lateral force on the actual chuck itself. The drive goes through the hole in the platform, and it's indexed into a bearing. Okay, so when you receive your sanders, this is the shipping carton. Just going to open this up just so you can see. There's a little tiny bit of assembly, not much. But this is what you're going to get. So this is the hose for your foot switch. That is the bladder for your foot switch, and that's the controller for the foot switch. Now, the load displacement bearings and your center bearing are already in place, and this is the centering pin for your drive. So you just thread this into place, and you're good to go. This is the ultra-high molecular density plastic. You want to make sure that that sandpaper, when you change it, is dead flush with that outside edge. Usually machinists will actually cant or soften an edge, but I made it very clear to the machine shop that did this job to make sure that that outside edge is razor sharp. So that's what's coming your way. Any more questions? Feel free to call. The top of the disc has a 24-foot spherical radius. Very, very shallow radius. If you had a ball 48 feet high and you cut out a 9-inch disc, that's how shallow the radius is. The reason we have the load displacement bearings is, once again, you don't put any undue pressure or lateral pressure on the chuck of the drill press. So you can push down, the disc is supported. So the disc itself is Velcro, so we have a Velcro conversion kit on here. The cloth sandpaper on the outside is actually two-sided tape, and I get quite a bit of mileage out of one strip of that tape. 80 grit, 80 grit. So I do have that single clamp that holds the platform to the table of the drill press to make sure it doesn't rotate when you flick the switch. If you have a similar drill press where you have a magnetic switch, another hockey puck trick. Have a look at this. So I have to credit my good friend Jeff Lawton, local electronic genius, for this idea. So the problem was, because it's a magnetic switch, each time I used my air switch and released it, then it would shut off and I'd have to open this up and so it just wasn't working. So again, the hockey puck to the rescue. So a little piece of two-sided tape, and we clip that closed. So now it's like there's a finger underneath this plate holding the thing on. So thank you, Jeff, for your electronic brilliance. So once again, another low-tech solution to a high-tech challenge. I got 4 more compensated nuts to do today, so giddy up. And that is basically what you got. Now, even though this sandpaper is fine, it doesn't need to be changed yet, but I'm doing it for your sake, for all of you guys that have your disc sanders. I just want to show you what's involved in just swapping out a fresh strip. So it's two-sided tape. Get that tape off first. These are the replacement sanding strips. When you peel back, you'll see an arrow marked. This is the side that you want to put down. That is the actual factory edge. So when you put this on, you want to make sure that the bottom edge of the sandpaper is perfectly level with the bottom edge of the disc. So you just kind of run your thumb along the bottom just to ensure that you're dead flush. Just kind of peel it off as we go, using my thumb to just kind of feel underneath. Now the reason you're doing that is these discs are machined so that this bottom edge, that edge is not canted. It is sharp like a knife. And this is what gives you that perfect inside cut on that compensated ledge. So ultimately, you want that to be dead flush. You don't want it to be proud or shy of that bottom edge. So you want to take the time to put this on and get it right, because that piece that I took off, you saw earlier, I mean, I've already done 12 compensated nuts on that piece, and it wasn't finished yet. I could have done a lot more, but I'm just taking the time to show you this so that when it comes time for you guys to change your sandpaper, you know what to shoot for. I disconnect it from the chuck just so that it's easier to rotate. Now you'll see as we come to the home stretch here, you'll see that this sandpaper is left longer than you need. Now this one side, this cant is already cut. So when you get to this point, I just mark a little tick mark with a Sharpie on the top and on the bottom edge. Sort of connect the dots. So I'm happy with that angle. I've got a perfect match on the angle. It's a good idea to cut it just a little tiny bit long and then trim it back, and that's what I'm about to do now. So I'm just trimming back just a hair all the way across. If it is cut ever so slightly short, you can actually pull it and stretch it. And there we go. We're all set up and ready to go. So I loosen off this clamp on the platform as well, just so the platform is able to move slightly. Now we're lifting this up into the chuck. Before you tighten the clamp on the actual platform, that should be free to move. So you want to tighten up the table first to make sure it's absolutely perpendicular to the chuck before you tighten the chuck. As soon as you feel that chuck start to grab a little bit on that hex drive, then you know that the three jaws have come down and locked into the hex drive. You got a positive lock, and that prevents any slippage. And now I snug that down tight. Once that's done, then this clamp on the outside that basically clamps the platform to the table, I snug that down, and we're ready to go. This is a Cocobolo steel string acoustic guitar bridge blank that I just cut. And I'm bringing you into the jointer because I want to show you that's laying on the jointer table, which is ground 100% flat. We are going to put a radius on the foot of that bridge, and this is done using this new sander. We're going to put the radius on the foot of this bridge. And I check on the underside. I don't know how much the camera's going to pick up there, but I check for the swirl marks. So the swirl marks have come to about here. We still haven't gone to that outside tip. So radius that just a little further. Now it doesn't matter where you set this on here because this is a spherical radius. It's like the outside diameter of a ball, 48 feet high. So I'm going to lean a little bit more on this side. I'm just looking for those swirl marks. Back to the joiner table. So I need to bring you in this close just to give you an appreciation for how shallow that radius is. So what happens now when I push down on that, you see that little tiny bit of flex? That's exactly what you want, because what that guarantees is the outside perimeter of that bridge has 100% contact, and then that little tiny bit of clamping pressure gives you 100% contact. I've never had one of these bridges come off. Brian is on his way in to pick up his XLT, and there's no doubt about it, the lion's share of these XLTs have gone out for all the apartment dwellers that are basically locked down in their apartments over the last year, and it looks like the coming year. Well, they're at least working on their own guitars, if not starting a little home-based business and offering these services to others. They're realizing, you know something? I don't even need a workshop to do fret dresses, fret jobs, setups, swapping out electronics, and just working on guitars in the safety and comfort of their own apartment. So Brian will be here in a few minutes to pick this one up.